Okay, I get started. Welcome to Unit 25. We are talking about a new integration method, which is integration by parts. And we will have several parts. So the first is we will just describe the method. Then we will give some examples, not too many. And then third, we will look at the merry-go-round method. And fourth, a very cool method, which is the tic-tac-toe method. No, I don't start again. Let's look at the method. So you know all the product rule. Let me just write that down big. So we take uv prime is u prime v plus uv prime. That's the product rule. And we write this, if we integrate this, let's just integrate this. We can integrate this whole thing. And what we get is on the left-hand side, because of the fundamental theorem of calculus, we get v, uv. And here we write this as v du, and the other thing we write as u dv. Now we can solve for integral u dv, which is uv minus the integral v du. And that's the method. That's the integration method of parts. So part 2 of this lecture is about examples. Okay, part 2 is about examples. We see that it's uv. We get uv. Okay, part 2 is examples. We first look at the example when we have x times cosine x dx. So I want to identify the u part, and the u part I always write an arrow down, and for the v part, the dv part, I put an arrow up so that we get v. So what I have is I'm just leave the u part. We get uv, which is sinus x, and then minus the integral where we integrate and differentiate at the same time. So what we have is 1 and then sinus x dx, and we know that is actually just that's x sinus x plus cosine x plus c. So that was example A. So again, what we have is we have that formula u dv is the uv minus the integral v du. And so that's what we have done. We have identified the u part here. That was the part which we differentiate. And we have identified the dv part, which is this, which we have integrated. Example B is maybe we take x minus 1 times e to the x dx. So again, we want to identify the part which we differentiate and the part which we integrate. So what I'm doing here, I'm differentiating the polynomial. That's easier to differentiate and integrate the exponential. So what we get is we leave the part which we differentiate at first, we integrate this, and then we take the integral where we differentiate this 1 times e to the x dx, which is x minus 1 e to the x minus e to the x plus c. Cool. So that was part B. Now let's just go a little bit steeper, and I want to integrate the log x dx. So here we don't have any second function, right? We don't have any second function. So what do we do if we don't have a second function? We can just make us a second function. And that's what I'm doing here. I'm just adding a second function, which is 1. Of course, that's the same thing. And now we can integrate we can let's just use the rule here. We like to differentiate the log, and we like to integrate this. Differentiating the log is always something nice to do, because we get something simple, 1 over x. So when we do that, we get the log of x times x, and then minus the integral when we take the derivative and we integrate. So x over x dx. So that's equal to log x times x minus x plus c. So that's part C. So here already a little trick here to make this go better. Actually, I want to keep this short, and I'm doing the merry-go-round problem next. Sometimes we don't get through in one step, we have to use 2 steps, and so let me just get an example without merry-go-round. If you take x squared sinus x dx, so we have to do it twice. So we have to do twice. Here we differentiate this, we integrate that, so we get the x squared times minus cosine x, and then minus is plus the integral 2x cosine x dx. Now you see we have the integral which we have seen before, but sometimes we don't succeed by going twice. And an example where this happens is we have if we have integral e to the x sinus x dx. So let's just try. So I try to, maybe I differentiate this and I integrate this. So what do we get? We get e to the x, we integrate minus cosine x, and then minus, it's plus, differentiate e to the x cosine x dx. So we didn't get through. We have still a problem here, or something we don't know. So we can do it again. So we do it again. We just differentiate this and integrate that. And so that gives us integrate is sinus e to the x sinus x minus the integral e to the x sinus x dx. Now we have reached the place where we started with. Right, so this integral here, let's call this I. We have ended up again with this integral I. But now what we can do is we can just solve for this I. So let me just put that up here like that. And what we can do is we can solve for I, for that unknown thing. And we see when we take it on the other side, we get 2I is equal to minus e to the x cosine x plus e to the x sinus x. And so I, which we want to know, is just minus e to the x cosine x plus e to the x sinus x over 2. Finally, we have that very cool tic-tac-toe method. And this is useful if we have to do integration by parts several times. For example, if we are doing x to the 3 sinus x dx. So that's a relatively complicated thing. We need to do it. We need three integration by parts. And that's just a little bit, too much work. So what we can do is we make a table. So what we do is we make a table here. And so in the first thing we write the x to the 3. Well, above we write the x to the here, we write the sinus x. And then we have another column here where we put signs. And this column is always filled with the same sign. So we always put here a plus, we always put the minus, we always put a plus, we always put minus, and so on. What we do in the left column, we differentiate. So here we differentiate. We get 3x squared. So we get 6x, we get 6, and we get 0. So I don't need even the last one. Here we integrate. So when I integrate sinus x, I get minus cosine x. Then I get minus sinus x, then I get cosine x. I always integrate, and so on. So I don't actually need even this column here. And here comes the tic-tac-toe. So tic-tac-toe goes like that. We have this tic-tac-toe. Here we have a kind of one step more. And we just add up everything which we have. So we have x to the 3 minus x to the 3 cosine x. Here we have a minus and a minus, so we get plus 3x squared sinus x. And in the next step we have a plus everything, also plus 6x cosine x. And finally we have a minus 6 times sinus x. So that's the method, and I can actually just see whether this is right here. Just check that quickly here with a computer. So here is my laptop, and I start Mathematica.